Section 6.3 is about trig functions of any angle. Let's check out our objectives. First, we're going to find angles that are coterminal with a given angle, and then find the complement and supplement of a given angle. So coterminal is going to be new for us. Then we're going to determine the 6 trigonometric function values for any angle in standard position when the coordinates of a point on the terminal side are known. Excellent. Then we're going to find function values for any angle whose terminal side lies on an axis. That's going to be new. And then find function values for any angle whose terminal side makes an angle of 30, 45, or 60 with the x-axis. So that'll be some things that we've already done. Again, working with those terminal sides is going to be new for us. And then we're going to use our calculator to find function values and angles. Excellent. Okay, so lots of good stuff in this section here. Let's see what we got first. Topic 1, angles, rotations, and degree measure. So some vocabulary. Angle. Angle, standard position. All right. So I can draw angles in a variety of ways. So I could draw an angle, the same angle, in a variety of different orientations. So we've got to talk about the standard position for an angle, so I can figure out when I look at a picture if any of these angles happen to be the same. It would be easier to identify them if they all looked the same. I tried to draw them the same. I'm not sure if they're all roughly the same, but I've got a bunch of angles right here. So standard position. We're going to define our standard position based off of coordinate system, so x, y axes. Okay, so x and y. And then we can have, if we have the bottom side of our angle flat on the x-axis, then we want to measure our angle up from the x-axis. So instead of having a variety of different ways to draw the same angle, we're going to pick them all up and move them so that they're flat against the x-axis and measure the angle as an arc going up above the x-axis. Okay, so that's what an angle might look like. Now, as you can see in this picture below, we've got a few more sets of terminology to go along with it. So we have our initial side of the angle and our terminal side of the angle being between them. We also use the word vertex for the point in the middle of the angle. It's the angle itself. We want the vertex at the origin so that we can measure this angle right here. So we have our angle theta measured between its initial side and its terminal side. Now, angles don't have to be in quadrant 1. They can be in quadrant 2 or 3. Okay, so if our angle has an initial side on the x-axis, all of our initial sides are going to be on the x-axis. So initial side on the x-axis. Sometimes the terminal sides will be in other quadrants. And this angle, it's still an angle. It's just an obtuse angle. That would be the positive rotation for this angle. Positive rotations rotate up from the x-axis. So they're heading above the x-axis. Positive rotation for this angle. Okay? So initial side and terminal side. I'm going to get back to this next picture once I get a few more. Initial side and terminal side. So along the x-axis, our first side on the x-axis is our initial. And then the terminal side is just wherever I get to. So terminal side or terminal side, depending on how big my angle gets to. So terminal side or terminal side, depending on how large. I've got two different angles right here with two different terminal sides. So terminal side is the final side. I guess instead of drawing pictures, they probably want me to write words here. But initial or terminal, I'm drawing pictures. So terminal, there are two different terminal sides. It's just how far my angle opens up to. Quadrant is which quadrant it's in. It can be in quadrants 1, 2, 3, 4. So again, we know our quadrants are 1, 2, 3, and 4. Okay? Now, when an angle goes beyond quadrant 2 into 3 or 4, we can talk about it in two different ways. So first of all, this angle, if I measured its positive rotation, would be quite large, past a full line. So we can also talk about it in terms of its negative rotation or negative angle. Angles can be positive or negative. Okay, depending on if you're rotating in a positive direction, which is actually counterclockwise. It moves from a positive x towards the positive y. So it moves in a counterclockwise direction versus a negative rotation is in the clockwise direction. Okay, so this would be a positive rotation in the pink there and a negative rotation in the orange. Okay, all angles have both positive and negative rotations. We want to talk about whichever of them is the smaller, whichever one is less than 180. 180 degrees are in a straight line. So in this situation, the positive rotation is less than a straight line. If I did the negative rotation going backwards, it's larger than a straight line. So it has a negative measure, but we don't commonly talk about it unless it is the smaller. So we most commonly talk about angles in quadrants 1 and 2 in terms of positive angles. We talk about angles that are in quadrants 3 and 4 in terms of negative angles. Just because it's most common doesn't mean it's the only way it's ever done, but just for some reference points. All right, let's see what else we can learn about here. First of all, I want to find one positive and one negative angle that is coterminal with each of the following and state what quadrant they are in. Okay, now other things that we want to know about for each of the axes before I can do this is that the axes themselves can refer to angles. So, for example, if I measure from the x-axis itself, which is a measurement of 0 degrees, because I have no angle measurement there, all the way over to the other side of the x-axis, I have gone 180 degrees. Okay? If I come all the way back around, I've gone 360 degrees. So we often say that 0 and 360 degrees are in the same place. They are coterminal. Okay. So we want to find one positive and one negative angle that is coterminal with each of the following and state what quadrant they are in. Okay? So first of all, this angle, 74 degrees. 90 degrees would be up at the y-axis. I'm going to leave all of these up here. 90 degrees would be up at the y-axis. If this is 90 degrees, 180 degrees, if I add another 90 down here, this would be 270 degrees. Or if I went backwards, it would be negative 90 degrees, negative 180 degrees, negative 270 degrees, if you see that pattern. Okay? So, because I am below 90, we're going to be in quadrant 1. So, this is our angle of 74 degrees. It's in quadrant 1. I want two angles, one that is positive coterminal and one that is negative coterminal. For the positive coterminal, the coterminal side must be the same, so I cannot draw this in a different spot. I cannot put this in quadrant 2, 3, or 4. It's going to be in quadrant 1. It has to be coterminal, which means the terminal side is the same. But I can wrap around all the way and get there again. In that case, I went all the way back to 360 and another 74 beyond it. So the angle that is 360 plus 74, 360 plus 74 is the angle that is 434 degrees, is the positive is one possible positive coterminal. I could find another by going around again 360 twice back to my angle, or 3 times back to my angle. Okay. Now for the negative. If instead I started at the x-axis and went in reverse to the angle, I'm actually subtracting from 360 to find out how much is left. So I've gone negative 90, then I've gone negative 180, then negative 270, and this little bit left. If I take 360 and subtract 74, because it's 74 shy of negative 360, which would be back to that 0 line. Subtract 74, that gives me 286 as the negative angle. So actually, technically, you're probably subtracting it in the reverse order. 74 minus 360 gives me the negative. So we'll switch the order of those. I subtracted them backwards because I knew I was going to have a negative answer. You should probably subtract them in the forward direction. So I'll reverse the order on that and say what we should have done is 74 minus 360 degrees equals negative 286 degrees. There we go. Because it needed to be negative because I went in the opposite orientation. Two angles that make the same exact coterminal line, just created differently. Now, we are going to eventually want the simplest representation. That's one of the reasons we talk about this. The simplest representation of this one is the 74 that we had initially had. But those two are definitely larger, more complicated to discuss. They happen to be the same angle, though. Part B. Okay, so let's get an idea what this would look like. A quick sketch. I know that negative 90 is down here. Negative 83 is not quite there. So this would be the angle negative 81.3 degrees. It is in quadrant 4. That's the first thing I'm asked, is what quadrant that angle is in. Quadrant 4, IV. Then find some coterminals. Okay, so the first is the positive. So if I take the positive, wrap around to here, that it was 360 minus 81.3, or it's really plus a negative 81, so it's the same idea as the 360 plus 74. I'm adding the angle just happens to be negative. Okay, so 360 plus a negative 81.3 is 278.7 degrees. That's the same thing, it's just going in the positive direction around it. There are 278 degrees going this way. All right. If I wanted one positive and one negative, to do the negative, we're going to have to wrap twice. So we're going to start on the negative side all the way around past it to it again. So we're going to take the angle, negative 81.3, and we're going to subtract another 360 degrees. So negative 81.3 minus 360 gives us a coterminal of negative 441.3 degrees. Got some coterminal angles there.